Hey everybody, thanks for tuning in. I got some new formulas that are called the sum and difference formulas involving cosine and sine. And here they are in front of you. They're also on the cheat sheet. You've got a couple different ones for cosine, whether you're taking the difference here or whether you're taking the sum. And same thing down here for sine. Again, they're all available on the cheat sheet. And I expected to memorize them, and this video is going to show you how to apply them in different scenarios. So let's just jump into a couple examples. Example number 1, it says that let sine A, that means angle A, equal 3/5. And cosine of angle B, so two different angles, equals 2/5. Find sine of A plus B. So the first is just to identify which formula we want to use. And so if we look back here, the sine of the sum of two angles is going to be represented with this. So I'm going to copy that down here. So I got sine A cosine B plus sine B cosine A. And a couple of these things are already given to us, meaning that cosine B is 2/5. That's going to be put right there. And sine A is 3/5. That's going to be put right there. So if you think about this, it's going to be 3/5 times 2/5. But then it says I need sine of B. And all I have is cosine of B. Same thing, I need cosine of A, but all I have is sine of A. And so this is where some old stuff's going to come in. Remember when we did reference angles? If you have an angle A here, and we know that sine is opposite over hypotenuse, then using the Pythagorean theorem, meaning 3 squared plus something squared is 5 squared, and moving this around, I could find out that that adjacent side is 4, and then cosine of that angle is adjacent over hypotenuse, which is 4 over 5. So cosine of A is 4 over 5. So if I do kind of the same idea here with setting up a reference angle for angle B, it says that cosine of angle B is 2/5. Again, cosine's adjacent over hypotenuse. And now if I want to find this missing side here, it'd be 2 squared plus mark squared equals 5 squared. Again, question mark squared. You can slow this down if you need to check it out. It would be this. And if I take the square root, I get that missing side is going to be the square root of 21. And you could use a calculator or something, but let's just leave it as the square root of 21. So I can say that sine of B is opposite over hypotenuse. And that's going to get plugged in right here. So then what is the final answer going to be? Well, it's going to be 6 over 25, right? Multiplication, you multiply straight across, plus 4 rad 21 over 25. So the exact answer for this, when I combine them, sine of A plus B would be 6 plus 4 rad 21 over 25. All right, I'll let you review that if you want to, but I want to do a couple more examples. So let's try one with cosine. So cosine of A minus B is a slightly different formula. We can reference it here, cosine of A minus B. And so if I write that down, it's going to be cosine A, cosine B, plus sine A sine B. And again, I have some of these. You know, sine B is going to go right here. Cosine A is going to go right here. So I'm going to have 1/3 times cosine B, which I don't have yet, plus sine A, which I don't have yet, times sine B. So I'd encourage you right now to pause the video and try to set up your triangles. I'm going to do it in just a moment. But again, if I set up a reference angle for A, I'm going to go a little bit quicker than the last example. It says that cosine is 1/3 adjacent over hypotenuse. And so 1 squared, I'll call this y, 1 squared plus y squared equals 3 squared. So y squared equals 8. Y equals the square root of 8. So sine of A, you guessed it, is the square root of 8 over 3, right? Opposite over hypotenuse. So that's going to go right here, because that's sine of A. So now all I need is cosine of B. So again, if I set up a reference angle for B, woo, there we go. Sine is this. And now I need to find the adjacent side. So again, x squared plus 4 squared is 9 squared. Pythagorean is our friend. We've got 81 minus 16. (81 minus 16). 81 minus 16. We got 5, 6, 65. So x equals the square root of 65. So cosine of that angle is going to be square root of 65 over 9. So if I multiply straight across, I'm going to have square root of 65 over 27 plus 4 rad 8 over 27. And we'll just leave it unsimplified for now, but when I combine my terms, because they have a common denominator, that would be our cosine of A minus B. Whoop. All right, so a little bit, almost just as much algebra as we would trig. So check that out. Nice, another example. Let's do one more. It's a little bit more clever here. It says using the sum and difference formulas, find cosine of 15 degrees. So remember, the unit circle gives us values for 30 degrees. We had this like rad 3 over 2 and 1/2. And we had 45 degrees, which was rad 2 over 2, rad 2 over 2. And we had 60 degrees, and you start seeing some similar values. And so let's just say for kicks that I encourage you to use this formula. And if you remember, I think we did it on the last slide, but it looks something like this. And if we're slightly clever here, if we think about the goal, which is we want to have 15 degrees, well, one way we could do that is think of 15, here's the key thing, we'll start by, think of 15 as 45 minus 30. So if you think of A as 45, then we could say that we've got, cosine of 45. And if you think of, B as 30, and we start kind of using this formula but filling in these values, the nice thing about this is these are all values on the unit circle. And so if I wanted to find cosine of 15 degrees, right, because that's the goal, well, now I can use the values that I just listed, over here. And so what I've got is cosine of 45, cosine of 30, plus sine of 45 times sine of 30. And what we've got is a rad 6 over 4. Again, it becomes a rad 6 because they're both radicals, plus a rad 2 over 4. And so an exact value, without using technology, of cosine 15 degrees would be rad 6 plus rad 2 over 4. So kind of a different way of thinking. One thing I might ask for on your next quiz is, you can do different combinations of this using the unit circle. And so, for instance, if I asked, we'll just wrap it up here with kind of a future question, but if I ask you to find, say, sine of 75, then you could think of this as, well, I could break it up into, sine 45 plus 30, and then use the sum formula for sine, and then, sine 45 plus 30, we could write as sine 45 cosine 30, right, because this is A and B, plus cosine 45 sine 30, and then you use your unit circle to find those values. So I'll leave that for you to try for fun, but thank you guys for watching. Again, sum and difference formulas. Take it easy, and we'll see you soon.